Thrust 1 10-score got the name TACIT, which stands for the Tennessee Advanced Solar Conversion and Innovation Team. And the hope is that collectively the scientists throughout the state will work on new ways to capture solar energy and convert it into some usable energy format. Everybody who looks at the energy problem realizes that fossil fuels are not sustainable and that the sun is probably our singular solution to solving this problem. And there has to be a sort of a portfolio of technologies that can try to capture. We have essentially a thin film silicon-based system. This is to try to take nanoparticles, impregnate them into these very thin silicon materials so that although you use less material, you actually have a little bit higher performance on it, say a per mass basis. We have polymer chemists who are working on novel polymers that they can both synthesize but also assemble into organic photovoltaic materials that will sort of solve some of the traditional limitations in organic PV. And then we have a group that actually tries to do it the same way that nature does it, using biological material to use the native process of photosynthesis to capture the light and convert it into either a fuel or in some cases directly into electricity. In Thrust 1 we have 4 different faculty that are at University of Memphis, 2 in the Department of Chemistry and 2 in the Department of Physics. One of those, Sanjay Mishra, who's a professor of physics, is actually a material scientist who makes nanoparticles. These are titanium oxide nanoparticles, which he fabricates with unique properties. And here's an instance where a physicist across the state has 2 graduate students, they make something, they send it over here, and my biochemistry students work with that material. And so the hope is that with the fundamental sciences and engineering that we have, we will start to build in technologies that are both more efficient, more sustainable, and more cost effective than, say, typical crystalline silicon.